In this video, I'm going to show you how to use the Tetris diagram and geomorphic unit identification app. This app has been pulled out of the larger restoration effectiveness app, so some things are missing. And I just tried to throw in what was necessary for the Tetris diagrams and then identifying geomorphic units. So when this pops up, you're going to have to select your name from the current user dropdown, and then the stream that you're going to be working on from the stream dropdown. Both these lists can be edited down here, so if you want to add crews, you hit edit crew list. You can change it here. The crew nickname's just for fun, so that doesn't really matter. But you hit the plus button, and you can add people's names and the crew abbreviation. And then for editing the stream list, click down here, and if you want to add a new one, you would hit the plus button. And this little edit box lets you change these, so if you try and do anything here, it's going to give you an error. So you hit the edit box first, and then you can fill these out. Likewise, up here I can't change any of this. Let's say I wanted to change the name of the stream, or give it a different section type, or change the width. I'd have to hit edit, and then you can come in here and change these. So that's to prevent people from accidentally editing stream names as section names that already have data associated with them in the database. So be careful there. You can delete them as well with the trash can. Once you've selected those, then you go to do your Tetris diagram builder or identify geomorphic units. And let's start with this one because it's a little less complicated. This is just a tool to help you figure out what the geomorphic unit is that you're looking at in the field. So this is the new tier system. You'll see in the Tetris diagram builder it's the old tier system, but works very well for the Tetris diagrams, and this could help you really pinpoint a geomorphic unit if you're not entirely sure. So this tier 1, you select the stage height, whether it's in channel or out of channel. Notice geomorphic position goes away when you select out of channel because it's not relevant. So in channel, then the shape, we have our classic concavities, convexities, and plane bed. And if you select one of those, you can skip this section in the box if you want to. If you already know that, you can just select a concavity from the list of all the concavities that are available, or convexity, what have you. But that can be a very long list, especially with something like convexities. So there's these other morphological properties, the position, the orientation, and the forcing mechanism of the geomorphic unit. These can help you break down the final tier 3 list. So if we just add bank attached, you don't have to fill out all these, so if I do bank attached, I've already broken this list down quite a bit more to only show bank attached convexities. And you can go even further and say only show me bank attached streamwise convexities. It's not much different, so if we did radial, then there. That breaks it down. The only possible radial downstream bank attached convexity is a confluence bar. So again, you can skip all these options if you know exactly what you're looking for, but if you need some help trying to figure out what this thing is that you're looking at, then you can use these to help break down this list. And that information, if you get confused, is in this little help button. So this shows you, but shows you how to break down the list using these fields. And when you select one, it's going to give you the information here, basically the same information that is used in these drop downs and in the master table that Joe Wheaton made to give you more information. And then if a photo from a textbook that I have exists, then you can click on this and get more information and a description and a picture. But this doesn't exist for all of them. If we do a bar force pool, for example, doesn't have a picture example, but it still has all this information. And so another thing that'll be helpful in here when you're out in the field is the similar to field. The bar force pool is similar to a structurally forced pool, but forced by a bar shunting flow against a resistant boundary. So that can help you, once you've looked at all this and picked up a unit, maybe it's not quite right, maybe check the similar to unit. And you can get a description there. scour pool. So this can be helpful if you're just trying to figure out what a unit is out in the field. And it does contain the outer channel units, so this active floodplain, the fans, the hill slope, and the inactive terrace. And none of these have, I think none of these have, yeah, none of these are going to have a geo example. They need to be taken from textbooks or online sources. So that's that. Could be helpful. But then the Tetris diagram builder works as follows. If you have previous Tetris diagrams, you can click here and get a list. I'll show you that in a sec. But here, the Tetris diagram builder, you tap this and select. It's going to automatically give you the section name that you selected on the first page, but you can change that here if necessary, and change your crew if necessary, and then the date if necessary. The only thing you would have to fill in is the diagram number, which has to be a 3-digit number. So if I put in 10, for example, it's going to give me an error. If you hit OK, it's going to bring you right back to that field. If you hit revert record, then it's going to ask you if you want to revert it, and it's just going to delete that field. Once you put in a 3-digit number, you can hit create DWS, and it's going to give you the Tetris diagram thing. So these are all of the attributes of the unit that you're filling out. And so let's ignore these buttons right now. And if you're just going out and selecting a unit from scratch, you're going to select the unit number, and that makes this pop up, which is the same drop-down tiers. However, you notice there's tier 1 through tier 4. This is the old geomorphic unit tier system, but it does include all of the new geomorphic units. So tier 1 is still in channel, out of channel, and tier 2 is still concavities, convexities, planar features. This also has channel margins to include the undercut banks. But then tier 3, rather than this being an optional morphological feature or characteristic, this is the actual position. So bank attached, channel spanning, or mid-channel. And then tier 4 is the actual geomorphic unit that you're calling out. The same thing happens here, where you can get a descriptor or a description and a little diagram or picture of the type of unit, and that could help you. Then you need to select the bank attachment, and if you do bank attach, you need river left or river right. If you do channel spanning, it'll automatically select both, and mid channel will automatically select mid. But this is very important because it determines where in the diagram the unit is going to start. So we'll say a bank attached, let's just do a channel spanning structurally forced pool. You'll notice along the way some things auto-populate, some things will disappear. For example, if I come back here after unit width is already 1 and I change it, it's going to get rid of unit width because bank attached can be a unit width of 1, meaning it spans the channel 100%, but that's not typical. Otherwise you would have hit channel spanning. So that makes unit width disappear. And you'll notice a bunch of those along the way, and you just have to learn what happens when you click what button. So I've got my structurally forced pool, it's channel spanning, bank attachment is both, and then unit location is upstream and downstream. And this exists because the purpose of this app originally was to create Tetris geomorphic unit assemblages around some restoration structure. So there's an upstream of the structure and a downstream of the structure. So you'll just have to use this to your advantage if you're not doing this around creating the diagrams around a specific point and just trying to do a big block of units. We'll start with upstream for the demonstration. The start distance is the starting point from what would be a structure. In some cases, it might just be some point in the field. So 0 would be the starting point. But you can move away from that, and I'll show you that in the next unit. And then the unit length is the channel unit, the number of channel unit widths that this unit goes upstream or downstream. So we're not measuring in meters, or and for length and distance, we're not measuring in meters or percent up and downstream. This is in channel unit width. So on a stream with a 6 meter bankful width, that would be one channel unit width is 6. So if I'm going to say 1 here, it means that the structurally forced pool is going up roughly 6 meters, or 1 channel unit width in this test stream. When the width is 1, I can leave that. The unit widths rather than channel unit widths are measured in percentage across the bankfold channel. So 1 would be 100%, meaning this unit spans 100% of the bankfold channel. Percent bar exposure doesn't apply to anything except concavities, so it's going to pop up automatically as NA. But if you had a bar, you would say what percentage it's exposed above water, and this is really just, stage dependent characteristic, but it could come in handy for certain bars, and definitely you expect things like riffles to potentially be low, as in 0.1, or maybe completely underwater all the time. And then a lot of other bars, of course, would have more. But then when you select one of these, if you had a bar, it's also going to ask what's the vegetation status, and this gives us a rough age of bars. If it's bare, that means it could be fairly new because it hasn't had time to have vegetation established. Vegetating would be a lot of forbs and grasses and sedges and rushes, those kinds of things that can grow and establish quickly. And then vegetated would be woody vegetation. And it's just a general way of looking at the age of bars. Bare are the youngest, vegetating are fairly older, they've had time for vegetation, but then vegetated must have been there for a little while because it takes longer for woody vegetation to establish. Put that back on NA. Then we have a max depth for the units, -99 for both this, and the average depth will come up automatically if you select a bar. Otherwise, you're just going to pick one of these categories for max depth. We'll give this one 55 centimeters for the pool. And then for pools, it's riffle crest depth, and otherwise all other units would be an average depth. And so in this case, let's say the riffle crest is 20 centimeters. Then a dominant forcing mechanism. I typically only use these for forced units, and most often really only use them for forced bars and forced pools. But this appears for every unit, so if you have, for example, an undercut and you can see what's forcing the undercut, you could throw that in here as well. Let's say this structurally forced pool was created by large woody debris. And then dominant substrate for the unit, and reserve NA for units that I don't care what the substrate is, or in particular undercuts. They're typically found in fines anyway, so it's really hard to make an undercut if you have an armored cobble bank. So let's say this structurally forced pool has a cobble dominant substrate. So I've just filled out one whole unit. This is all the information for that unit. And these are stored globally. So this hasn't been registered yet. You have to hit the plus button to throw it down here into the Tetris diagram. So when I hit plus, there it creates the unit. It gives you a couple of these. You can't edit this one. This is going to generate the list showing what units are in the diagram. And so I've got the most important ones for because you can't see everything, and you may be creating the next unit. You want to be able to know where the last unit was, starting distance was, where its location was, the length and width, and that'll help you determine where the next unit needs to go as far as numbers. Let's make another one real quick, and using these hot buttons. So these are the most common units out here where we work, just a basic run, a rapid, a pool, and a bar. And these are run and rapid are of geomorphic unit, but then a pool and bar could obviously be many different ones. So for us, they're most often structurally forced pools, so that's what's created automatically. On forced bar, those are our most common bars. And then rapid and run will just create a run and a rapid. So these hot buttons are to make the process faster. If you have a lot of runs and rapids, you're going to be using these buttons a lot, and it auto-populates the common measurements that we see out here for max depth, riffle crest, and substrate, or average depth for both those. So you notice rapids and max depths are usually deeper, and the substrate's usually bolder, and the average depth stays the same between those two. That's fairly typical for us. The bar, it's going to fill in these -99s. You're going to have see a structure as a force bar. We often, with the restoration structures, we force bars, so that's why that comes up automatically. Cobble tends to be the dominant substrate. We got these negative 99s, and then percent bar exposure is left blank, because if something's blank and you try and hit plus, I'll accept bar exposure. I take that back. Jeez. Let's bring that guy back up. If you have a blank thing in here, then it's gonna give you an error, and you won't be able to send the unit down to the list and put it in the diagram. So these buttons are here to make you spend a little less time going through each field, and when it's not necessary, when you have units that are pretty typical throughout your stream or reach. One thing to look for when you're using these, though, is it's also so there's a little glitch on the desktop, but this doesn't appear in the app. This little portal down here interferes with the Geomorphic unit tier pop-up window, so I just moved it up here. But what I wanted to show is that when you put one of these in and then pull up the Geomorphic unit, is it's with those hot buttons, it's automatically filling these out as well. So for example, you can't just rely on these buttons. If I put in a structurally forced pool with the pool button, then it's automatically making it channel spanning and attached to both. So if that's not what you want, then you can't just go in these, and even if all these are what you wanted, you still are going to have to come in to the Geomorphic unit tiers and potentially change the positioning. So that's just something to keep in mind. So when you create a new one, we're going to just say that this pool extends down below as well. So now instead of upstream, it says downstream right there. So I hit plus, it sends it down there, and say there's a run downstream as well. This is where the start distance comes in handy, and then these numbers as well. So I know that this downstream unit started at 0 and went for 1 channel unit width downstream. So then the next unit must start at 1 as well, and it'll go for 1. So when I hit plus, there, put the run below it. Now just as an example to show why that's important, if you hit the edit button and bring that unit back up so you can make changes on it, leave it at downstream. I'll put this at 0.25, meaning it starts 0.25 downstream of this white line. And I hit add, that's where it's going to put the run. So the units will go on top of each other, and this is where the Tetris comes in, because let's say this is the base unit assemblage here with a big pool, and then it comes down into a run. But maybe there was a piece of mid-channel wood in the middle, which created a bar around on top of the pool and in front of the run. So I'm going to put a bar, and then I'm going to change the unit from bank attached to mid-channel. So there's mid. I'm going to say the start distance is 0.25 and the length is 0.5. We'll give it a width of 50%. Let's call it 60%. Exposure 0.1. It's a force bar, so it's up high. It's bare. It's fairly new. Say it was forced by large woody debris, and it's gravel. So now when I throw this on, this is two things to note here. So this is a mid-channel force bar, and I want it to appear right in here. But when you add a mid-channel structure, you need to give it a reference for where it is in the middle of the bank full channel. So whenever you add a mid-channel one, the diagram goes blank, and so does this cross-distance category down here. So this is saying how far from river right does that unit start. Well, I said that the unit is 0.6 wide, so if I put it at 0.2, that means it's going to start 20% across from river right and end 0.6, 60% away from that 20%. So just watch if that maybe it'll make sense when you see it. 20%, and boom. So it threw it right in the middle of that pool. So that means it starts 20% from river right, there's 60% wide, and that leaves 20% on river left to the bank. Now, I actually kind of wanted this force bar to extend down into the run a little bit, so I'm going to hit the little pencil to edit it. I'm going to make the length be 1 instead. And now I'll change that. If I hit add again, it's going to edit that, and there's my nice big force bar in the middle of it. And this is where the Tetris units start to come out, where you have, you can build units around. You know, I could put the equivalent of 3 structurally forced pools to create this box, this little wedge in this box, and then a bar around it, but then I'd have to also make 3 for the run to create these little boxes. So it's best often to just build your base units below and then throw smaller units on top of that so that you can get this effect. So that's the basics of that. You can delete each of the units down here, and again the pencils, throw them back up here to where you can edit them. Be careful with these hot buttons because they may not react exactly what you're to how you're expecting, but as you get the hang of it, what you'll find is it's often, when you're learning, easiest to just make a unit, throw it down here, see what it looks like, and if it's not quite right, then edit it and change some of these numbers until it looks the way you expect it. This little light bulb icon has a description with some stuff that can be helpful, and the one thing I guess I forgot to mention is, yeah, we're doing channel unit widths, but the diagram only has space for 1 channel unit width upstream of a structure and 6 downstream. So what that means for you, if you're using this to try and do a semi-continuous survey, is that you can go a total of 7 channel unit widths of a particular spot in the stream. One of those channel unit widths is above the point, though. And then some more instructions on how to treat undercuts. Let's just do an undercut real quick right now. There's no hot button for undercut, but and so you'll have to go through the whole thing here. We'll make it unit number 5 since that's the next unit. It's in-channel unit. It's channel margins. It's bank attached, and we call it an undercut. Then you're going to have to give it which side of the bank it's on. Let's say river left. Still have to do upstream or downstream. Let's put it downstream. And then still have to do start distance. Let's say it starts at 0 and goes for 1. Also, these, yes, there's drop downs, but you can also directly edit these. So there's no 1.5 in this drop down, but maybe I want it to be 1.5, so I'm going to change that to 1.5. Unit width is nothing, so for the undercuts, and that's what's explained in this light bulb, that you record NA in the unit width field and use the max depth and average depth to give the depths of the undercut. So I'm going to put that at 0. Nothing for bar exposure. Let's say the max depth is 40 and the average depth is 25. I do NA for dominant forcing mechanism and dominant substrate. You can put these in if you want, but they're not necessary. So then when you hit add, it's going to throw the undercuts into the 2 side margins here of the Tetris diagram. So there's the yellow undercut there. So another thing to keep in mind here too, river left and river right are swapped on the diagram because we look at river left and river right looking downstream, but I most often do these streams working, or doing these surveys working upstream, or looking upstream. I feel like units are much easier to see if you're looking upstream as well, so these are swapped so that you can hold the Tetris diagram up, look upstream, and it'll match. So that, keep that in mind if you're ever looking downstream. Okay, then we also have photos, so if you want to throw in photos from directions, river right, river left, upstream and downstream, then you can throw these in there, and they'll be directly referenced to the Tetris diagram for you to check out later and see if it actually matches up. Up at the top, it's going to show the stream name and the current diagram you're on. There's 3 buttons up here. The trash can deletes the current Tetris diagram that you're working on. You can also hit this thing that looks like a bulleted list, and that brings you to a list of previously made diagrams, and the magnifying glass over on the left will take you to that one. So if I hit one of these others, it brings up the other one. So you can edit it later or come back and fix it. Then you can also go back and hit Tetris Diagram Builder again to create a new diagram, or if you're already in here, you can hit this new button, this little plus, and that'll take you to this where you can create the next diagram. And there you have a blank slate. Okay, so then some of the other tools in here, you can export the data, and this is going to throw a CSV onto your iPad, which you can download from using iTunes or email it to yourself within the FileMaker app. But if you do it, it's going to take the Tetris diagram information and put it into a table for you. Because I'm on my desktop, it automatically opened an Excel of the CSV, but it has the section or stream that you're in, the structured number, which is the same as the diagram number, habitat units, and then all the tiers that went into building the geomorphic assemblage, and the basic, all the things you filled out for that unit, the start distance, length, width, depths, substrate, bar exposure, bar vegetation type, and the forcing mechanism. So that you can get when you're all done doing your survey. And then down here there's also generate frag stats raster. So if you run that, as you get more data, these drop downs will become more important, but you get to select the year of diagrams you want to turn into rasters, the stream, and if you hit yes for the whole section, it's going to do all diagrams that were created on the stream test in the year 2017. If you hit no, you can select individual diagrams that you've created. Let's just do, I'll show you, if you hit go after selecting all that, show you what one of those looks like. It pumps out as ASCII rasters, and then also a descriptors function for use in frag stats. And all it's doing is creating an ASCII raster of all the numbers. So all these are converted based on the bankful width of a stream. That's how many rows and columns there are, to give you a rough estimate. So this is a way to convert from the channel unit widths back to meters, so you can actually use the raster for something. Negative 9,989 is for blank values. You'll notice that the Tetris diagram that we made doesn't extend beyond all the way down to 6 channel unit widths. That's why there's going to be a bunch of blank values. And so each of these is going to be a raster cell, and the numbers correlate to a particular unit. So let's see, there's 302 and 304. Let's see what those are. When you create a raster, it also creates this descriptors list, and if we look at that, and we had 302 right here, which is a glide, and 304, which is a run. So if you're going to use these in frag stats, that's where those come in. Otherwise, you can link these two tables together if you want to open the raster into GIS or something like that, or use an Excel spreadsheet, which I've done, to take these whole rasters and compare them to the next year's rasters. If you're looking at sort of a geomorphic unit change detection type thing. I'll get rid of that. Okay. You'd be able to say, once you'd be able to use a database to link those numbers to the actual name of the units, and you can see year to year what units have changed to what. If you're going to use frag stats, which I need to make another video on, you can create a batch file, because if you have done 1,000, let's say 1,000 different Tetris diagrams, but then you have you're going to have an ASCII raster for every single unit, And so if you're going into frag stats and you want to do some analysis on each Tetris diagram, you would have to individually import one of these. So instead, the app creates a batch file which just tells frag stats where all a list of all the rasters that you made are. So right now I only have 2 made, but it knows, gives the the folder directory for each of those 2 rasters, and then these numbers are the size of the raster, what type of raster, all the different numbers that FragStats needs to understand the raster. So if you're interested in doing some FragStats analysis on these, then I can do another video on that and show that. Otherwise, you would just need to look at these rasters that are created. So that's the gist of it. If you have any questions, just send me an email at reid.camp@gmail.com. Thanks.